So now we will discuss about homologous series. So what is homologous series basically? It's a series of compounds that differ successively by CH2 group. A series of organic compounds that differ successively by CH2 group. CH2 group. Okay. So successive in the sense what? For suppose if I take second compound, you have to compare either it with first compound or third compound. It's not like you are taking first compound and 10th compound. Okay, you have to take the successive compounds, and if you see the difference in their composition, they differ by CH2 group. Okay, what is the name of this CH2 group? It is called as methylene group. Okay, and it will be having a mass of how much? It will be having 14 units of mass. Okay, because one carbon atom 12 and each hydrogen 1, so it will be having 14 AMU mass. Okay, so which differ successively by CH2, they are called homologous series. Okay, I mean those compounds are called homologous and the series is called homologous series. What do we call the members in this series? The members are called homologues. And what do we call this phenomena? The phenomena in which the organic compounds differ by methylene group, the phenomena is called homology. Members are called homologues, phenomena is homology, and the series is called homologous series. So as an example, if I take methane, then ethane, propane, butane, pentane, etc. Okay, so if I take this, so what is this series of compound called? They are called actually alkanes, right? Now alkanes is an example of homologous series, because alkanes is a series of members which differ by CH2 group. Now what do we call the members in this group? That is methane, ethane, propane. These members are called what? These members are called homologues. Okay, now observe the difference here. CH4, C2H6. If you see the successive difference, there is difference of one carbon atom and two hydrogen atoms. Similarly, compare second with the third. There is a difference of CH2. Again, compare 3 with 4. There is a difference of CH2. So, such kind of compounds which differ successively by CH2 group, they are called homologues, and the whole series is called homologous series. Okay. Now, you just need to observe one thing here. For suppose if I start with propane, okay, this is propane. Now how do I find the previous member of this homologous series? Like I know propane formula, that is C3H8. I just want to know the previous member family. So if you want to know the formula of previous member, so what you have to do is you have to do minus CH2. That means you have to delete CH2 from propane. For suppose I want to find the next member in the series, like I want to find the next member of propane. So what I have to do here, I have to add CH2 group. So you just check here, if you do minus CH2 from propane, you will get ethane. If you add CH2, you will get butane. So if you want to find the next member in the series, do addition of CH2. If you want to find the previous member in the series, do subtraction of CH2. Okay. So this is all about homologous series. Now we'll see some characteristics of it. So what are the characteristics of homologous series? The first characteristics, according to the definition itself, we can say, so the members in the series differ by what? They differ by methylene group, that is CH2 group. That means if you take the difference in mass for the successive members, It will be 14 AMU units, okay, because as I told, one carbon 12 units and two hydrogens 2 units, okay. Now if you take the members of this homologous series, all the members will have same functional group in them. Like for suppose if I take alkene family, all of them will have double bond, like ethene, propene, butene, all of them have double bond. For suppose if I take alcohol family, like methyl alcohol, ethyl alcohol, propyl alcohol, all the members in the series will have the same functional group, that is alcohol, okay. So you take any member of the homologous series, they possess same functional group. And as I told you earlier, functional group will decide the chemical properties. So if they have same functional group, it means that they possess similar chemical properties. Chemical properties will be similar. And as the functional group is same, they will have same general formula. For suppose if you take alkane members like methane, ethane, propane, every member in the alkane family has same general formula, that is CnH2n plus 2. Okay. Now same functional group, so they will have same method of preparation. Like the preparation methods that we use for preparing the members, it will be almost the same. Okay. Then what will be different? They differ in physical properties. Physical properties of homologues will be different. Physical properties means what? Like density, you know, the volume, melting points, boiling points, that will be different. For example, if I take as an example, if I take alkane members, I'm just taking methane, ethane, propane, butane, pentane, etc. I'm just taking 5 members here. So if you see the homologues here from top to bottom, if we go from top to bottom, there is an increase in the number of atoms, isn't it? Number of atoms increasing. Okay. Why it's increasing? Because you know when you go to the next member in the series, there will be addition of CH2. So number of atoms is increasing. First point. So if number of atoms increases, what happens to the mass of the compound? Mass of the compound also increases. So if mass increases, what happens to density? Density is nothing but mass by volume. So as mass increases, what happens to density? Density also increases. So if mass increases, density increases, then what happens to melting and boiling points? They also do increase, right? As the molecular mass increases, melting and boiling points also increases. So I'm just writing fourth point here, melting point MP, boiling point BP. So they also increases. So like this, there will be difference in physical properties, like solubility decreases from top to bottom. So when you take chemical properties, they will be similar because all of them possess same functional group. But then they do differ in what? They do differ in physical properties. So this is all about homologous series. They differ by CH2 group, that is by a mass of 14 AMU. They have same functional group, similar chemical properties, same general formula, same method of preparation, but they differ in what? They differ in physical properties. So I hope you have understood this. If there is any doubt related to this topic, please comment in the chat section. I'll try to clear your doubts. If you have understood, then well and good. So as of now, thank you so much.